So in this case now, in this part, we are required to prove that the opposite angle of a cyclic quad are supplementary. So it means when we take the two angles that are opposite in the cyclic quadrilateral and we add them, we're going to get what is 180, meaning they are supplementary. They will add up to 180 degrees. Even if we can take D and B, there's still going to give us 180. So now the first thing when we prove, we're going to construct. And then before you construct, you need to check on what you are required to prove. If you are required to prove that A and C are equal, you're going to construct what you are not proving, what you are not required to prove. And then if you are required to prove that B plus D is equal to 180, then you're going to your construction will be based on A and C. Let's take a look. So now in this instant, let's say we are required to prove that A plus C it is equal to 180 degrees. So if we are required to prove that, then we're going to construction, and then our construction will be join at DE and BE. Join DE and BE. Okay, let's go join the two. So we're going to construct this. Now we have BE. Let's join BE. We're going to have BE. There we go. And then also we're going to have DE. Let's join DE. Right. Okay. So now based on that, now let's say this is E1 and then we have our E2. So now our E1 that will be equal to 2 times angle A. That will be 2 times angle A, right? The reason will be angle at the center it is equal to 2 times angle at the circumference. And then second part, now we're going to look at E2, which is equal to 2 times angle C. Now the very same thing, angle at the center it is equal to 2 times angle at the circumference. Right? Now, if we add angle E1 plus angle E2, that will give us 360. That will give us 360, reason being it's revolution. Or you can use angles around the point. Angles around the point, they give us 360. So now E1, it is equal to 2A. It means in this instant now, I can write E1, I can write in the form of 2A because E1 is equal to 2 times A. Then plus now E2, that will be equal to C. Then I can write it in the form of E2, it is equal to angle C, which is equal to 360 degrees. Right? Then I have a common factor in this case. I have a common factor of 2. Then let's take out the common factor. We're going to have 2 into A plus angle C, which is 360 degrees. Right? Then we can divide both sides. We can divide both sides by 2. We can divide both sides by 2. Then 2 divided by 2, that will give us 1. And then we'll remain with angle A plus angle C, which it is equal to 360 degrees. 360 degrees. So now we have proven that the opposite angles, if we were to take this angle and this angle, we add them, we're going to get 360. Let's take a look at GeoGebra and see if the statement or the theorem, what the theorem says, it's true. Okay, let's see. We have this now. This is our cyclic chord. This is our cyclic chord. It says the opposite angles of a cyclic chord are supplementary. Let's look at that. Let's also look at that. Right. Let me reduce the magnitude of this so that we can size of this so that we can be able to see this angle. Okay, that is 92. Right. Let's add them and see if indeed they are supplementary. Plus 87 plus 9. That is 180. That means it is true they are supplementary. Then let's measure the other two opposite angles. We have this and that, 78, and then we have this and that. Okay. Let me reduce a bit the magnitude of that. So that we can see it's 101. Right. So now in that case, we're going to have 101,3 plus 78,7. That gives us 180. So it is true indeed that the opposite angles of cyclic quadrilateral are supplementary. Okay. Then we have proven that the opposite angles of a cyclic quad are supplementary. If we take this and then we add it with this, regardless of the magnitude, they're going to give us 180. Doesn't mean that A, it has to be 90, C, it has to be 90. It can be any of any size. Right. Okay, let's look at